3 recording, and we are live. Do I have LSP? If I don't, I am dropping this thing right now. It's enough not knowing Haskell. Okay, so what should we do here today? So we should add a new, oh man, okay. So describe to me, Nathan, describe to the audience, I guess, what we should do today, and then you describe me what we plan to do to add such thing. So please.
I don't know what you mean.
Just describe what we're gonna do, man. Just that.
Yeah, sometimes.
Okay, how? And that's the thing.
So let's go to our data type.
Type. I think the types, let me see, data type. This.
Yeah.
We added this last session, right?
Anonymous.
Yes. I love him, man. That's like powerful abstractions.
Oh. Oh wait.
It's literally JSON, man. It's literally JSON.
There's a huge problem there, folks.
Which is?
What are records composed of?
Well,
no, even easier. Even better.
Hmm.
How do you write a record?
How do you write a record? What do you mean?
Yeah, like how do you type like a record, right? How do you write it, like in a programming language?
Well,
What are the pieces that you have in any programming language, right?
well, you
What's
have.
it?
I see. You don't want me to give you a full example. You have a field in the declaration. You have. Oh man, this thing breaks on
no
Linux.
declaration, like the expression itself, right?
The expression itself. So it's just the field and the value.
Yeah. So you guys have only types, right?
No,
So
this is
describing
the
only
type.
Yeah, you need the labels there.
Why? Oh, okay. This was the discussion we had. I had this
Otherwise,
discussion.
it's a tuple.
Yes, I had the discussion with Lemus, and we said, okay, we don't need the labels here, like because we are assuming it's in order, which I don't like. But yeah, that was a choice.
But
We have
still,
the labels here. That's what I'm saying. Where is it?
yeah, but see, if you have different labels, but the same types, they would match.
No,
right?
yes.
When they
What I'm saying is we are assuming there is no possibility of you typing them out of order. That's just to simplify, man. Like there's no really like deep thinking behind it.
Well, let's go there to the types. So some types. What do you need?
I don't know. You ask me, and I ask you.
Yeah. So sure, like when you are declaring like the type of the thing, we have like also the labels,
Mhm.
right, of the possible variants, and we have like the type they carry, right?
Okay.
And then
How should we
there
call
are
it?
few-
Tsum? I think that's not a good name.
I don't really know.
Let me just check my messages here. Nobody's pinging me. No. Okay, so let's just do tsum, and it has a list of 2 things. I screwed the types. So tuple of text with the
Yeah,
type.
then it's the decision part. I get that.
Here, by the way, should be maybe, right?
That's what I'm going to talk about. Like, there is a decision to be made there, right? Just for example, the first thing is that you can have only the tags, right? So you are writing assuming that it's
Yeah.
a maybe, right? That
Yeah,
there's
like-
a possibility of not having yes, like this. Exactly.
Mhm.
That's the thing. Something like OCaml and car, yeah, they have like a maybe type, right? So you
Yeah.
either have no type or you have a type. If you want more than one thing in this type, then it's a tuple, right?
Mm-hmm.
But we also have the choice of doing like Haskell. So if you take a look on the application, you have type. it's carrying two types.
Yeah.
It's not carrying one type that happens to be a pair. It's not like that, right?
Yeah.
So that's the first decision. Um, and I would argue that we should go with the Haskell approach, because that way we can do partial application on those things.
I see. So what you're saying is that, okay, I'm not sharing the full thing. Let me just switch my screen. Oh, I'm not recording, right? The full screen. Yeah, let's go with it. So we have this issue here, right? Which is, wait, just a second, not a C term. Can you see? This is not broken, right?
Yeah, you can see it.
So let's see if it breaks the .NET. No, it doesn't. So, okay, let's just do an example here. So type ABC, because I know you can pipe, for example, a sum, right? So you can do 1, 2, 3, this. So that works, but I don't think you can with 2, right? Because, well, it's like if you need to define more, it's a tuple, right? So you don't have the partial application.
Yeah, that's pretty much it.
Yeah, okay. So I'm fine with it. I'll keep this open. I might need it. So
And then when people are like declaring, right, declaring the sum types, what we can do is we put on the in the environment, we put the type itself, right, if someone wants to use it, or something. And we can put functions in the environment, right? For example, declare, okay, like this type that you are declaring, right? This type. What we can do is do the following. We add a function in the environment called the application, and it takes like 2 types, right?
yeah.
That's a way for the thing to behave like a function, like Haskell does, like F# does. So yeah. Then yeah, we can do like a list of types, right, on the second item of the tuple.
Yeah, okay. This, right?
Yeah, I think that's the only thing we need. Yeah.
Okay, we also need this, right, for the declaration of it.
Yeah, we need that. No, wait,
No, we do, right? We need an expression for the thing.
I guess we do. The only thing is that we will not, well, maybe we will not have to return that from the.
Let's call, I got a better name.
Yeah, that's, I'm not sure if that's right, because
Yes, it's
like,
fine.
wouldn't you call the record or the tuple as the product? So
Wait,
then it's
if I would call, yes, they, okay.
when people say algebraic types, they talk about
Yeah.
sums and
Yes,
products,
yes.
right? But that's only the sum.
Well, we can, yeah, I see.
You can change that later, man. Like,
Yeah, that's
just
fine.
put a name for now.
Okay, so what we have here is just the same as this, but with a, yeah, that's the same, right? Just the labels with, so a tuple, text, of, and a field of,
Expression, right? Let's think about
they
that.
shouldn't be, I see, yeah, so, okay, let's do an example here. So, in that way, we have this, right? So if you're doing type, let's do Haskell's way. So ABC, and then you have something here. Oh, the first you don't. It's like SML. So, okay, and then you have A, and then let's suppose A doesn't have anything. B, and then B has something, which is, I don't know, integer. And then C has string. Text. Anyway, so okay, in this case, this is not an expression because this is the type itself. What we're talking on this algebraic is the application of it, but that's weird, right? It's not exactly that we want, like this. This would be that.
Yeah. It's because there are 2 things, Magita.
There's the
before
declaration and the usage, right?
No. Besides that, only talking about the usage, there are two things.
Hmm.
One thing is what you will return from the parser, right? And maybe,
What I will return from the parser on like this case, which is the usage exclusively.
yeah.
Okay.
So, like maybe, and that's a huge maybe, we don't need to return algebraic from the parser, right? Because as I told you,
Yeah, I get it. So this would just make sense if it was for declarations, right?
no. Wait, let me finish. Uh, because we might do that way of, oh, let's just parse as a function, and we will have that function in the environment, right?
Yeah, that's.
But maybe that's bad for errors. I'm not completely sure. So that's something we
What do
have
you mean
to
errors? We don't have error messages.
Well, but if we want in the future.
Yes, I see. Yeah. Can't we add metadata along with stuff on the prelude so we can check if this is actually from a type?
So there's no way to know that.
There is. You parse the thing. Oh, I see. You will parse, but then you don't know if it's a function declared or.
Yeah, you don't know yet. So yeah, but that's something that we need to think in the future. But the other thing is what the internals of type checking and evaluation will deal with. And those, I guess they will always need to deal with this algebraic, right?
Mm-hmm.
So we need him anyway. Maybe the parser will not return, but we need him anyway. Yeah. I guess so, yes.
Yeah, is there any other way to get the thing if not by a function? I'm thinking about it now. Because, dude, like, think
What
about,
do you mean?
like, for example, you do this. You declare, let's suppose we can, right? Right now we cannot even do this, but let's suppose you can declare this type, and then you do this. Now, this is valid, but it will parse as a function. But how do we distinct this from an application of this thing here that is part of this type from actually a normal function? I don't think there is any way, like on the error message part.
That's the easy part, man. That's just like casing. Like you don't allow a variable to be like uppercase on the first one, and you allow the text to only start.
Dude, that's kind of yeah.
No, that's the only way you distinguish on parsing. Like you have to have different.
Well,
like,
we
rules, right?
can invent a special syntax, right? Like.
No, we can't. I'm not
Like
saying it needs to be.
PHP, what do you think?
Yeah, I'm not saying it needs to be what I say.
Yeah, I get it.
Distinguish.
Mm-hmm.
Yeah. So yeah, dude, I don't think that is the way we do without the we're doing without the type values already. But I think we should spend some time thinking about the thing on parsing as a function or parsing as a proper expression, right?
Mm-hmm.
The first thing is, would we be able to do partial application if we are not parsing them as a function?
I think we can, but we would be doing the same thing.
What do you mean?
Let me think. Because without parsing as a function.
Right? We use B. And then let's assume we know it's a tag.
Let's do like integer, right? In this case.
Yeah. So we have B, right? Like to B1, for example, right? To be a partial application.
Yeah.
So sure, we know that is a tag, right? Because we have some way to distinguish. And then the thing is applied to one argument. We will infer that this is from a specific type. Like only you have in the B doesn't tell you shit, right?
Yeah.
You will look somewhere in the context to see, oh, the B it's from the type ABC and not the other one. So knowing that, we know what B expects, right? Like it's types that he needs to get.
Yeah, I agree.
now, how we do this? We see like what it is applied to, and based on that, what do we do? Like P1, we know its type. Let's suppose we know it fulfills the first type, and then we need to return something that expects an integer, right? But what do we return? Type-wise, we know, right? You would just return something that would get an integer and return something of the type ABC, right? Value-wise, how would that work? At the expression. Wow, I guess we can just add the list, right? In the sense that
Nice.
if you return an algebraic with the label B, and in the list it would have the X, right? And then it would return exactly that. If that's applied to something else, so you can attribute this to just a normal variable, right? So is that a problem? I don't think so. Oh, I guess what would happen, Mageta, is that on the application we would have to check if the thing is algebraic. See, because look at the following. Like, you understood the type part?
Yeah, I
I
think
can.
so. Hey, go again. Go again.
Okay, so if we have something like this B that receives integer, the way we can do partial application is just say, oh, B1, we'll just return, well, we first will like infer the type of B, right? We know from which type it is and what types it expects.
Yeah.
And from that, we just check, oh, the first thing being applied to is, oh.
The third? Wait, what's the problem?
Not sure, let me go on. So
Hello, Commander.
you take a look on B, and you see B. Yo, Commander. So we take a look on the B tag. We infer its type from the context, and then we know that it is getting like 2 integers, right? Then we see that is we do that shit, man.
Does the book on Benjamin?
Yeah, he doesn't go into like
No. Okay.
practical details of that, man. Okay, so the first thing is that the expression that the parser would return would already contain like a list of stuff, right?
Yeah.
When
okay,
you
I see.
write the thing, you would not do like okay, a way to explain is, do you know when you have like ABC as an application? A applies to B, and then the result of that to C.
Wait, say it again?
Copy and paste what I just pasted on chat.
Okay. Let me see here. ABC. Okay, what about ABC?
Based on the.
Oh, you want literally to do this?
No, yeah, but yeah. So suppose those are functions, right?
Yeah.
The way that will be parsed will not be A that has a list of B and C, right?
Mm-hmm.
It will be that way, like of okay, it's an application of A and B, and the result of that is applied to C, right?
Yeah.
That's the way the parser would return.
Mm-hmm.
In the case of the algebraic, that would not happen. It would return the tag applied on a list.
Yeah, so
that's
the
okay.
B and C would be applied to A, right?
Yeah, like
that what
it
you're
would
saying?
get like A
Something
and a
like this.
list of it. Yeah, exactly.
Mhm.
So that's the case with the algebraic, right? So, okay, the first thing is that. The other is, now we have the tag, we take a look on the environment, we get its type, we know which they are expecting. Then we have to match, right? Like, the first thing is that, yeah, we have to match if the things that we are receiving from the user, like the user gave us, we need to see if it matches with the type, right? If it does, but it didn't like reach the whole list, right? Like you are partially applying.
Okay.
And what you need to do is to return.
I see. You
it
get.
should be the type of a function,
Yes,
right,
I
that
see.
expects the rest,
Mm-hmm.
and in the end returns the type ABC, right?
Yeah, I see.
I think that that could be done. I'm not completely sure, but it sounds like it. And in the case you are like getting more stuff, right? In the case that you are passing more stuff, then you should, right?
Yeah, like this, right? So like this, we could basically exhaust the list. No, sorry. I think since is the list, man, can't we already just check with the arity of this? Yeah. Right?
Yeah. So I guess we can. Yes, exactly. The part that is like kind of strange is because with functions, you usually check in a different way, right? But yeah, I guess you're right. We can check exactly that way that you said.
Okay,
So
so
sure. Now that's the argument that sure, if we go from that on parsing and return the algebraic, we can already know how to type it. And do the partial application, even without using the function field.
yeah.
Now the other question is, Magenta, if we do the way with functions, do we have any advantage regarding the errors that we can give, right?
If we do, then as functions, if we have any advantage.
No, we
If
have
we
like
do away
this
with,
way.
is that what he said?
Huh?
If we don't do functions, do we have an advantage? Was that the question? I think
Yeah, kind of.
Okay.
It's like we have the two ways. We have the way with functions, and we have the way of returning the algebraic, right? So, do any of those have advantages slash disadvantages regarding errors, right? Yeah, that's the question. I would bet that the algebraic has better over messages, because I think that's often the case where you have like arity and such.
Mm-hmm.
But I guess that would only do something for us in the case of, can I say, in the case of you gave us more arguments than you should. Then we can say, oh, this tag B of the type ABC only takes a few parameters, not those that you passed. That would be a better type error, right?
Mm-hmm.
Because the function would not be able to tell you this. He would just say, oh, this here, it's not the type function, then it cannot be applied. It would say something like this. For the case of less, we don't have that, because we would return the partial application sheet, right? And that's also a thing. When we return the partial application sheet, and then you try to apply to something to like fulfill all the rest, if you're applying something that has the wrong type, he would give you exactly the same error message as functions also. So I guess we have little advantage on going the e-algebraic.
I see.
Because the only case I can think of him giving us like better error messages is when we, on one go, like on the first go, like you never partially applied, you are writing the tag in line, like as a literal, and you give more arguments than you should. I guess that's the only use case where I can see us having better error types. So yeah, maybe it's better for us to do the functions way, because I think it's much more straightforward to implement.
Yeah, I think
Just
so.
on the declaration, we add some things in the context, and they will just behave like normal functions, and all the errors for that are valid.
So okay, what do we do here then? Let's see.
Yeah, we still need that, right? So I guess we need to add the alias, man, because we cannot do shit without it.
Yeah. Okay, so let's do the following. I'll comment this. Okay. Let's first do the alias. Let's like minimize the load of stuff.
Yeah. Oh, I see. So adding the type alias, dealing with all the rest, and then adding that, right?
Yes, exactly.
Oh, yeah, that's smart.
So let's see. So the alias would be okay. Let me see if I'm right. So the way I imagine the alias working is you have you have just a label, and you can make a declaration where you receive another type, and then when you're gonna type check, you just find what you find you insert that thing in the environment of the type checking, and then you get that thing and reduce it, check it. I don't know about the kind, but anyway, like you reduce it, and then you compare. Okay, the reduction of that.
The kind you could just include in the context also, right?
The kind would be included in the context along with it. It makes sense.
Yeah, because right, if you know the type, then
Yeah.
you know its kind, and then you can also add the kind for the alias.
But and then the reduction of this is easy, right? Because you just
In theory, just getting to the
you
the
just
context,
add in the
right?
context. And, yeah, okay.
Yeah, I think there are some problems with that, Miguel.
Which is, can you mention?
Yeah.
Let's see.
Yes.
Which are, I guess. But anyway, go on.
Yeah, I need 1 second for me to write the example.
Alright, let's see. By the way, how are you doing, Commander? We can Lisp afterwards if you want. Waiting for Nathan. Let me pause this thing. Dude, how do I pause something on OBS? That's a good question.
You don't need to pause, man.
Yeah, but there's just an option like stop. There's no pauses anymore.
Oh.
I don't know what happened. I don't wanna FMPEG everything again.
Yeah. So that's the example, Miguel. I will send you on that. Let me just put the quotes here. Like that. So copy this code on the editor so people can see.
Yes. Dude, I can copy it. So let's see. The first one, you make a type A that is an alias in int, then a B that is an alias in A, and then A that is an alias in string. Okay, you're redefining this way, right?
Yeah.
Okay.
By the way, how long is your session today?
I think we can do like less because.
Wait, can you repeat one there?
How long is the session today?
Oh.
And are you doing Haskell?
Yes, unfortunately, yes.
You don't even know it.
Yes, I know.
Right, I see.
So
Enough, right? Like,
yeah,
you
okay.
know it
Like
now.
to be fair, it's like another ML, but it's the weird ML. It's like, you know, like on like Nordic people when they complain about like, oh no, like Danish people, they speak weird. Like, you know, like I can understand Norwegians. I saw a Swedish dude talking this. I can understand like
Yeah.
Norwegians just fine, but man, Danish, it's literally this. It's like to make it more comparable, like Latin. Like you understand Italian, Spanish well, and then you have French, which is like weirdo language. So that's
Don't
Haskell.
forget you are not.
So that's Haskell. Uh,
Yeah, so my question would be,
yeah. Okay. I
uh,
see. So
well, using the way you described, what problem that would generate on this piece of code?
yeah. So I see the problem of the redefinition because well, the type of A of B could be the string instead, right?
Yes, but
But
it should be the int, of
yes,
course, right?
but then I'm thinking, if you make an alias and you store the type,
Uh-huh.
then at the moment you shouldn't store. Okay, because here's the thing: this A is already an alias, right? So
Yes.
the thing to solve is, I think, would be searching if this thing is also an alias on the environment, and if it's a like a default type here, like if it's a primitive, let's call it that way, then that is finally like that's the bottom, right? And then we can have a way to compare. So we would need to reduce all these things as well recursively. So this way we don't have a problem because you would have, okay, A here, I reduce. What is A? An int. So okay, this is int. So if I redefine A, it doesn't matter.
Let me see. Like, I know that we need to unwrap. My question is, we doing that? Do we need to start the thing with the alias?
Oh,
Yeah.
I see. No, to
Yes.
type check, I don't think so, right?
Well, we have to think about like the 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 times I did with both things. I did the unwrap that you are saying.
Mm-hmm.
So when you have a type alias, you have the right side, and I use some kind of unwrap, right?
Yeah,
And
I
that
see.
unwrap, if it's a type alias, he will like extract what it was alias to, right?
Mm-hmm.
But I'm also, with the type alias, I'm also storing the value itself inside the alias, right? But I don't know if we need that. Then we need to think about that,
But
right?
think about this. This is Lisp, right? This is a pseudo Lisp, I guess. Does it make sense to force it not to be mutable on the reference? Like mutable in the sense of you do this.
I'm not sure what you mean.
Like for example, you do like the example of the hot reload. You remember? Not hot reload. It's not that, but I guess it's easy to explain that way. Like you redefine some parts of a function on some parts of the context, and all the parts that use that part, they automatically get re-referenced.
Yeah, I see, but that's a different thing. Yeah, I think that's a different thing, Peter.
What do you mean? It's the
Okay.
same, man. Like, I'll describe the way I see on the types. Like, you have A, and you did this. Like, let's invent a syntax. I don't know, def type, whatever. Def alias, I guess, right?
But we don't need that. I understand that you want to talk about the different semantics.
Okay, so let me do a. It was B, no, it was A, right? I redefined A. So, okay, if you do this, I think from the philosophy of the thing, that if you do this, like this thing here, and then you do this, and then, oh, sorry, I think it was this, right?
Marquesa, I get what you mean, but my points are we don't have a clue about hot reloading yet. And if you do that way, it will basically be dynamic scoping, right?
Yes.
And that is confusing as hell.
I don't see a problem with it, man.
It's because it's unpredictable, right? So you define something alias to A, and then if you redefine A but use B later, it will be a different.
I mean, we could give a warning. That's something we can do.
Okay, a warning.
Yeah, like a when
doing what?
because we know if something is already there, right? If we already have an alias or a type that is named as A,
You mean a warning on shadowing?
yes. Or we could even go fancier and say, okay, just give this warning. Okay, we would need another data structure probably to do that, but and then we save the states of the things we're shadowing, and then we see where they're being used. If they're being used in another type like you did here, then you give the warning.
Oh man, that would be.
But that's a job for Lemos to do.
Well, maybe it's not that hard if you are.
Yeah, probably you can do this with a state monad or something.
No, you don't need anything fancy. If the way you are doing is storing like just the reference, right? You could just like go to the context, see if the right side someone is using that name, and then you know that some alias use your alias to define like itself, right? So okay, so what you mean is okay if we are redefining A and someone is using A to define itself, then we give a warning.
Yes.
What kind of warning?
I don't know, like shadowing, like replacing definition that for a type or something like this.
I think that could work. Just sounds like a really bad default.
Oh, I can live with this. What do you think,
Because
Commander?
by default, Lexical is the easiest way to understand stuff.
I just think it is easier to do it this way now. That there's also that.
Well, but you already solved the problem. We won't wrap it. And maybe we start the thing inside the alias.
Wait, we will wrap it.
Unwrap it.
Oh yes, okay, yes, okay.
That's all, right? Does that relate? Maybe Commander can help us regarding on how the rot reload works, right? Because then you have more like future, how can I say, like information. Oh, Commander is muted, like
Okay.
totally muted.
Mm-hmm. So okay, let's do this then, man. Let's first define the alias and then we do the rest. So wait, it shouldn't be a type, right? It should be just it should be a type, right?
Wait.
Or should it be just an It should be a type, right?
Yeah, it should be a type, but
I'm
I'm
thinking-
thinking
oh,
about
man,
the part.
Yes, dude. How are we gonna get that thing without any special thing that it's actually a type variable? I think we can store it here.
Like regarding the normal types, like the types on like int and stuff, we don't have to special parse that anymore. That could just be a type alias that is already in the prelude.
Mm-hmm.
So you don't need to parse the type ints anymore, right? Yeah, we start by that. So you would base process type alias basically. The other thing it was regarding type variables, right? We either have a different syntax or I suppose we could also do some context trick.
Context trick.
Yeah, in the sense of if I declare a thing, if I declare the type variable, then what we add in the context is a type alias for a type variable. Right?
I didn't get it. Can you say it again?
Yes. So let's suppose we want one syntax for type, like this, right? Because we don't have like normal types anymore.
Mm-hmm.
Besides, like, wait, not even narrow. Not even narrow is special, I guess. Considering, yeah, depends. But well, what I mean is, let's suppose we want only one syntax for type alias and type variables, right? So
Okay.
maybe what we can do is, let's suppose we have something that creates a scope in which a type variable is valid, right? So what we could do is, when approaching that, we add in the context a type alias that has a type variable.
Okay, I think I see.
Because that way, you will still do the same. You always parse as a type alias. Like
Mhm.
every type is a type alias regarding the parser. Does that cause any problem? I guess
Good question.
it has the shadowing part, but that's not a huge problem. Like, you know, like if you declare that scope, then if there was something before, it's shadow. I don't think that's a problem. Yeah, I don't think that's a problem. So that might give us a really nice syntax, because then we don't need different syntax for type variables and type alias.
But do we want that?
Well, it's also very easy to just use a different syntax for type variable. But then you have to choose a syntax, right?
Yeah. Because I would just keep it. Like, I don't think it is a huge problem.
Wait, I don't know what are our syntax for.
Well,
variable.
for type variables? Oh, wait. Our syntax for type variables, they're always inside of for all.
You don't know what you mean.
Like, we just parse. I think what we're doing is that if we see for all, and then t, like this thing, is already a type
Wait,
variable.
yeah,
the
that's
only
not what I
case.
mean, Magita. What I
What?
mean is, if you go on the parser type, one of those will have to be parsing a type variable. Don't we have that? If we don't, that's a...
Wait. Say it again. I didn't get it.
We have the parser, the type parser, right?
Yes.
So it's R, a bunch of stuff.
Let's see.
One of those things needs to be parsing a type variable.
Yes, which is just a
Yeah,
generic.
It's...
It is the same as a. No, wait. What is this? I think this has some restrictions on like keywords. Type.
Maybe, yeah, I think it doesn't
Oh,
need.
dude. Okay, I think. Oh man. All right. Okay, I think I found out what we were doing. I didn't know about this, but we are parsing type variables with a bang in the front. So it's like instead of like this, it is like this. I mean, it's okay.
You can still do that, like.
Yeah, but that's how we identify them.
Oh, starting the reference.
Dude, that was funny. I discovered a piece of syntax I probably invented and I forgot.
Yeah, even though I don't think it's a good default, I'm still thinking, and I guess your idea, it works, Magit. Like, just storing the reference. The only thing that you have to take care is, okay, you give a warning after you check this stuff. So let's do that way, right? And that also simplifies a different thing, Magita, that maybe we're not aware of. It's because, suppose we go with the approach, okay, maybe we are doing or not unwrapping, maybe if we only need the unwrappy, what I will say doesn't apply.
Mm-hmm.
But if we also need a node to store the type alias with label and the type that is aliasing to, then the parser has a problem, right? Because let's suppose, okay, let me write to be more easy to
Okay.
understand. Yeah, take a look on what I wrote.
Let's see. Data type. Okay, let me copy
Yeah,
this and paste
paste
there.
that on the vector. So the one that you are proposing only has the text, right?
Yes.
So yeah, suppose that for some reason we would choose to do that way. That would be a problem for the parser, right? Because how will the parser return a type there when he has
Yes.
only the
How
name he
does
used,
it-
right?
I think. Okay, but think about this.
The way I solved that
Think about this.
was using.
If it is just the name, like for example, let me just keep it here. If it is just that, and we pass here as a, I don't know, A, let's say, we get the text, right? That's already enough to find in the context. If this A was already previously declared.
Wait, what I mean is, let's suppose you are using. You did some type alias, right?
Actually, two texts here, right?
Two text?
No, I see what you're doing. This type. Yeah, because this itself is a type that has a label as well, right?
Yeah, so what I mean is, suppose you have the text and the type. Why would that be a problem? Because the parser sees the name like A, but he doesn't know what it is alias to. So he has no way to return the text alias, text, and type, because he doesn't know the type.
Yeah,
The
but
parser does.
yeah, but that is not a problem on the if you look for the
yes,
reference.
that's what I'm saying. Like, if
Yeah,
you
okay.
only have the text, it's not a problem.
Mm-hmm.
So the way I solved doing my stuff was to have two nodes. You have a type alias and a type alias placeholder. So the placeholder is the one that the parser returns, right? And when he finds a placeholder, then he like kind of unwraps in a type alias, right?
Mm.
So yeah. So let's go back to our stuff. Like, can delete this.
Okay.
So yeah,
Close
let's go
this.
there. Have you added the type alias already?
No, I think I was doing here. So okay.
Okay.
So we should add.
Just the text.
Yeah.
Like
So
type alias, that's text.
this.
Yeah, we need a new context now.
So where's the context, man? I think it is on the evaluator.
That would not make sense.
Yeah. I think we have on typer. Yes. Okay.
Yeah,
It's here.
there. Wait, what? Oh, okay, yeah. Variable types is the. Oh shit! I always get confused with this. Okay. But
Where are we introducing stuff to there?
producing stuff?
Yeah, like adding stuff there. I think it's on the prelude, right? This.
Not sure what you.
Like, where are we adding definitions there?
Oh, yeah, it should be on the prelude, like typer prelude, right?
Yes, it's here.
Yeah, so let's go there on the context. We need to add a new one. Not a new thing in the context, a new context.
So we need to make a new one.
Yeah. But I mean, just adding on the typer env, right?
Oh, I see.
That record.
Okay.
Yeah.
And how should we call it?
That's your
Alias.
context. That's okay.
Yes, okay. Alias context, which is just a map, I assume.
Yeah, it's the same map, like text to type, I suppose.
Yes. What if you do Okay, like, do we want to go for the reference? Because then it would change, right?
Oh, we are going the reference already.
Yeah, but what happens if we save an alias?
Well, the type would be type alias way A, right? That's the way
Yeah,
we can
okay,
check and
but
stuff.
here's the thing, like, if we pass an alias of an alias, it will be... Okay, the other alias is already a type, so it doesn't matter. Okay.
Yeah.
Alright, so that's it, I guess. Okay. So... Let's see here. Let's go step by step. So you want to do the type checking first?
Wait, let me see if we need something more, man.
We're not even using this prelude, man. Why is this not even used?
Oh, okay, yeah, we need to try the declaration.
Declaration.
Yeah, on Dex. Yeah, I don't know where the declaration.
Let me just cue this. I think it is on the
Man, but
types.
I guess I would bet that the alias are probably the trickiest thing we have done so far.
Oh, wait a second. Here. So we are already handling declarations like here. So
Yeah.
decla type alias. I'll call it like this for now. Which is
It's
just
good.
the text type.
Yeah. That's a good thing to talk about. What are the different cases for a type alias and the type declaration? In the sense of type declaration is declaring a some type or a record, and type alias is like of pre-existent types. Are there which ways in which we need to treat them differently?
What do you mean by differently?
Well, differently.
No.
Like-
Okay, but like, what do you mean? What do you mean? Like, okay, where are you going to? I didn't get the context of the question.
Well, if we treat them the same, we only need one node. If you want to treat them differently, then we
Oh,
need
I
both.
see.
too.
I see. So you were asking me if we should do for general type declarations as
No, what I'm asking you is, do we need to treat them differently? Let's think about.
if we need to, not if we want to.
No, if we need to, right?
Yeah.
In which way would work differently, right?
Dude, where's
Like-
Lemons mapping this?
Mapping what?
These declarations, I have no idea. What the heck?
What do you mean mapping there?
Like, it's not on an expression node, so I don't know where he's mapping this. Let me see.
You didn't got what you mean by mapping.
Where is he actually getting this and evaluating this thing? I have no idea.
Evaluating this thing.
Yeah, because like on this declaration here, like
Well,
it's
isn't
not on
that
the
on the
expression.
evaluator?
I think so. Let me do a grep. Oh man, I should have added
Because, Magita, you don't have declarations inside the expression.
here. So
With the
he's
other
doing
ones.
that on the REPL. There is on the typer.
Yeah, he has there like eval declarations
here.
and type check declaration.
Let's see. Oh, dude, this code. Oh man, this is just okay. I see.
Well, declarations are your top level stuff, and inside that you have expressions, not the other way around.
Yeah, I get it. Okay, this is kind of confusing, but I get it.
So yeah, let's go back to the alias part. How would they work differently, right?
Oh wait, the alias you mean this, right?
Yeah, I mean, type alias and type declaration. In which way would they work differently, right? I only can think in one way right now. Doesn't mean that there aren't more, but the only way I can think right now it's kind inference, right? Wait, is that a problem? Not sure. Let's.
this, right? So like this from.
Even if you use only one node, you can still like just do the different syntax, right?
Yeah.
Yeah, not that. Like def type person, and then you define it to be a record, right?
Mm-hmm. In our case, we already have the anonymous record, which by the way is with this. So
It doesn't.
yeah, okay, I see. But just type here so I don't get confused. Yeah, both are. Yeah, okay.
Oh, don't think about the syntax, man.
Yeah, I like to think of this first. It helps.
Sure, just don't focus on the syntax, right? Focus on the behavior.
Okay, so what is the problem?
That is not a problem. We need
No.
to think if is there a problem.
Yeah, I don't see
The,
any.
the question is, we have when you are declaring a record or a sum type, that's one case. And the other case is you are just doing some alias. You are not declaring a new data type, right?
Yes.
So my question is, are there cases in which those two declarations behave differently?
I don't see any case.
Yeah, so far I also can't think of like any important one. Yeah, so let's do one node for now. If it comes to it, we can go back and create more if we think about later, right?
I'll just keep this here. Might be useful. So let's just
Yeah.
change to dec type. So
Okay.
we pick a text, told the
Yeah,
name.
because it will be both, right?
Yeah. Okay.
Now let's type checks.
Do we want to type check or eval first? Eval,
No, let's do the type check and
because you don't care for evaluating, right, Nathan?
that's not it. I guess it's easier for us to understand stuff type checking.
I think it's the opposite, but that's fine.
Really?
Yes. Let's see. So this is just a recursive case. No declaration font, type check. Okay, dude, I gotta understand what was this doing here.
Wait, before that, go to the type data type.
Here. Oh wait.
Yeah, we need to change that record, man. Like already.
And what do you suggest?
It's basically the same thing as the T algebraic. No, not the
What?
T alias, the T anonymous record. Sorry, I think
What?
I thought about it, but I didn't say it.
The TNO record. Okay, you just. I mean, we don't need to, but that's what I said. Like, we are.
No, even
Assuming-
if it's anonymous record, it needs to have a label.
No,
That's
dude,
an assumption that doesn't hold, my.
you're talking about the labels of the
Yeah, anonymous record need label.
of the fields of the labels or the record.
Like both need to have label.
Why?
Well, because that's the type of record. It has the label to a type.
No, dude.
Otherwise, they are tuples.
No, dude. This is, man. Like, what we're doing here is, this is just the fields, right? So we don't have any name for the anonymous record. Why would you need a name?
I get that. Those are the names of the fields.
No, there's no names here. No, but I get it. I get
Let
what.
me type it for you.
Okay. Let's see messages. How's it going? Come on, Nathan, type faster.
Come on, don't type in a big line. So, would you say those two types are different?
Yes.
They are not in our language so far. Because both types would be just like
I see,
record
because we're
strings.
not considering the name in the thing, right?
Yes.
I see. Let me just copy here so people. Yeah, so it's talking about this, right?
Yeah.
So in our case, these two records would be equal, right? How are you handling equality now that I think about it?
How we are what?
Handling equality now that I think about it.
Or what?
Because we have it, we just
Of
don't.
those?
Yes, we
Oh,
don't.
that's easy. The first thing we need to do is
Yeah.
sorting.
No, yeah, but I think we do have access to stuff. Let me remind myself what we did here. Because, dude, I had this discussion with Lemos and we opted for something. That typer. Unknown. Here, anonymous record. So we just pick the expression and we say fields. Then we map the second. Then we type check the second, which is it's a list of tuples, right? So it's like the labels and the things. So we just pick the
Oh,
the
okay, that's the
expressions.
expression. Oh, I see.
We reduce it and then we just build this. But then, like, you're right on equality of this thing, that would fail, right? No, not
Also
fail.
for different reasons. Also for different reasons, because how can I say? If you change the orders of the records, your
Yes.
types will be
No,
different,
yeah,
and you have no issue now.
yeah, this one we agreed with. Yeah, don't care. Like, let's not do that. That's what we said.
Okay.
So
yeah.
let's do text.
Right.
This. And here, I guess we can. Okay, we still need to do the thing, but for now, let's see. Let me just see here. Oh man, I'm not fluent in Haskell, so just bear with me. I think we can zip.
No, let's do the let's do the following. No, let's do the following. Go back with this code.
Wait a second.
Let's do the easy way.
No man, you're mocking me right now.
No, you are not understanding. I'm not saying the cursed way. I'm saying the easy way.
Yeah, that's the easy way.
No, it is not.
It is.
That's how I disagree with you on what is pragmatic.
What the heck, man?
Doing something that will be a shoot in your foot 5 seconds from now is not pragmatic.
Okay,
Yes.
how does this shoot in my foot?
No, you're not understanding.
Hmm.
I said let's do easy way, and what you understood is to do in a cursed way.
What the
That's
heck?
what you call pragmatic.
No, dude, what the heck? I didn't say anything. I just said,
You
let me
said-
do, because I was thinking of doing this, like a zip. And then you're saying, like, what? I don't get
Oh,
it.
okay. I thought you were saying, oh, let's do the right way already, right?
No.
But yeah, what I want to mean is just go back with that code, do the anonymous record as it was, add the new one as a comment, and let's solve the type alias without this first.
Yeah, but
Then
this
we add
this
those,
doesn't
right?
change anything.
This doesn't change anything.
Yeah.
It does, because for the record, and oh, okay, yeah. Well, now I have a question. Do you want this to be an anonymous record still, or do you want to be a nominal record, or you want both? Because if you want only the nominal, then it changes everything.
Yeah, I see.
If you want the anonymous
Yeah,
one,
okay.
we can do it already.
We're gonna change a few things that are breaking. Like in this, for example, we need to get the
Wait, but
second.
we need to know what we want, like it.
Yes, I see. So let me just do this real quick. So, oh, dude, this I don't remember if this is a function or something. I mean, I remember the fish, but
I mean, you just need to do a map first. Right?
yeah, but there was a fancy way to do this.
Yeah,
Is it a
fancy
bind?
way, it doesn't look.
It is not a bind. It's a composition, but not really. Because we need to apply. Okay, I know
You
the
see that
dumb.
you have fields there? Just map fields before sending to the for.
I know the dumb way. Okay, I see. Yeah. Okay, that's easy. Map. Oh wait, the function first, I think. Yeah. Okay. And I think it might be breaking somewhere else. Let me just check.
You just want the thing to compile, right?
Okay, that's it, I guess. Let me just see if it compiles. Oh, I can do it from here. Compile. Fancy.
What is fancy?
This compilation on Nix. Okay. Okay, typerinf, typer prelude. So we got an error here. Where is this?
If one thing you want the thing is to compile, then it's easier to comment.
Yes, but this is another thing, I think. We just added this. Oh, I see, it's building the thing, yeah.
The new one, yeah. You needed another map.empty.
Where is that file though? Oh man, I
Wow.
compiled with Nix. Wait, it doesn't show the thing unless
You can just look for the name, right?
Yeah, let me. How do we compile? It was stack build, I think. Yes.
But it's easier to look for the name.
Yeah, I can click here. That's the. It's easier actually.
Well, not if you need to compile first.
Well, I have to compile Nix anyway. Here I can just click. So what
So
was
you're
the?
using Emacs to click.
Yes. It's
I
extensible.
see.
Extensible. I never sold the Emacs as a selling point of like not clicking.
As
That's like
mouseless.
yeah, that's like a Vimers bullshit. Okay, this. And then we can compile again.
Wait. No, that's wrong, Magita. You need to add one after the other map.empty.
One after. Oh wait, yes. Okay, I thought it was like the thing.
Oh, like an argument for the
Yeah. Oh, this. Sorry.
I think it's weird the tooling not warn you about that.
Yes, actually it did, I think, but is it not compiling? What the heck? Oh wait, it's another thing.
Oh, okay, yeah,
Yeah.
pattern matching. You needed another underscore.
On this. Oh, I see here. Dude, what the heck, man?
Yeah.
Oh, here I
Other
need map empty. Compile again.
Oh, dude, we have quite a few things to do after the declaration of new types.
Man, this is propagating a lot. At least we have like
A type checker to tell us where to add stuff.
yes. No, but type checking is useless, man.
Well, kind of, right, Magita? Because if you are changing stuff just to compile now, then we have to take a look on them later. Because they will compile but not be right.
Yeah. Mm-hmm. That's preventing us from forgetting something. At least like forgetting to change something here. Arising at print. This is not an error, is it? Oh, it is an error. What the heck? Oh no, it's finished. It's just a warning that got like this. Anyway. Alright, so it does compile. That's better than not compiling. So, okay.
Probably.
So this is where Lemos is doing the magic. What the heck? So let's just make a new thing and then we guess.
Wait, are we missing something first? Did we? Oh, okay, yeah, records, Magenta. You have to take a decision.
Wait, on where?
On records. Do you want only anonymous records, only nominal records, or both?
Oh, I remember you asked that, but I don't think I said anything.
Yeah.
So, dude, what is the easiest thing we can do right now? I think it's just keeping the anonymous records, right?
The easiest thing is just keeping the anonymous records.
Yes. So let's just do it, and then later I think we can add the nominal records.
Yeah, let me just think about.
Because like we can make an alias with the anonymous record, right?
Yeah, that's exactly the thing I'm thinking about. Let me see. How does F sharp behaves on that? Can you take a look?
Oh, F sharp. I think I have that terminal.
I'm not even sure if you can do that.
Yeah, you can. ABC. Yeah, I do this all the time, by the way.
Really?
Kind of cursed, but yeah.
Yeah.
Oopsie. Int. Oh, sorry. Oh man.
Okay, I see how that would work. I see. If you do the following, Magenta. If you do.
It doesn't. What? It didn't show when I. Oh, okay.
You are just typing the.
Yeah, I know, but I wanted it to display to me this thing, but it didn't because of the comma.
It's not an X.
Semicolon.
Yeah, not only that, you typing ABC there will never return you.
No,
something
yes,
else.
I know, but anyway.
Yeah, so the way it behaves is the following, Magenta. Let's suppose you add person 1 and you say it has a int, and then you add person 2 and say it's a int, right?
I see. So
Then you declare one that is person 1, one that is person 2, and they have the same format, right? They were both type alias. If they are nominal, then they will not match. But if they are structural, they will match. So it does work, but it's not the same as nominal. Just because you are aliasing an anonymous record doesn't make it nominal. Yeah.
okay, so let me see what Lemons is doing on the value here, on this. So he's doing.
Then let's fix the other stuff already, like the anonymous record stuff.
Let me do this then. I can, right? I can. So what is the other stuff? Just making. Wait, what is the other stuff on the anonymous record you're talking about?
You guys have the anonymous records before adding those things, right? Declaration
Yes.
type and the alias.
Yeah.
So those things are probably wrong. So let's fix that first.
Okay, but I'm thinking here.
Because it's easier even.
Yeah, okay, bye. Bye.
That always happens with me.
Yes. Okay, so fix what? So what do you think is wrong? I think the
Wow,
equality.
everything.
Oh, thank you. Equality. I think it is
For
wrong.
sure.
Where's-
Let's start with by type check.
I don't
right?
even know where we're doing equality, to be fair.
So, okay, to start there, like the anonymous record, the type check, right? So let's see. You have expressions, the second, labels, the first. Okay. Wait. Wait. Why did you? Oh, I see. Because you wanted only one, I guess. Oh, and that's why you zip. That's why you zipping later.
Yes.
Yeah, but we don't need that, right? We can just map it and sort it.
Yeah.
And
Okay.
that's it.
Mhm. Yeah.
Yeah. So you can just get the fields, like map the second.
Yeah, but dude, like that's not changing anything, right?
Yeah. You can keep the zip there.
It's
But
trash, but
there-
it's my trash code.
Yeah, so let me see. Now that you have this separated, use the for to read. Oh, it's an expression. So you are type checking and then reducing. Do we need to reduce stuff there?
Well, I thought of reducing because. Okay,
I don't think
theoretically,
we want to
we.
reduce it.
I mean, we do.
Because-
Let me see here. I remember doing these ones. Let me see.
Yeah, the reason we don't want to reduce, it's
Dude,
because
what the heck? We didn't even add it here.
added where?
Here. On the reduce type.
Ah.
So we should be doing
How is
that.
that, how is that compiled then?
No, it is compiling because it's just a warning on the incomplete pattern matchings.
Oh, okay.
It's not an error.
Oh.
But I think we can do this. Like we can remove the. Where's the thing, man? E unknown. Is. So let's do this. We remove do.
Yeah, the reason we don't have to, we maybe don't want to reduce Magenta, it's because when you don't reduce, you have more information to give errors, right? And then you only reduce when you need, like on comparison and stuff.
Okay.
Yeah, but that's easy, right? You just map the types on reduce again.
So fields. We can implement the reduce here. That's not what I'm saying.
Yes.
So anonymous record that will pick. Okay, we just map, right?
Yes.
So, oh wait, sorry. So let me do this. Let me do in a let, man. It would be kind of cursed doing this. So reduced fields, reduced.
Do you need the int? Oh, you do.
You do, yeah. Only if it's in a do that you don't.
Oh.
Map. Let me think here. So we need to. Let me think in terms of lambdas because it's easier. So we pick the two things.
It's a lot easier.
So we pick A and B. Oh, let's name it properly. So the label. Oh, we don't care for the label, right? And
We care because we need to return it, right?
yeah, okay. The label and the type.
Yeah, that's really nice.
And from this we do just
Label
reduce.
and reduce the type.
So reduce type, pass in the type, and then we build a tuple. Oopsie. With the label. Okay, I know what Lemus would do. I'm pretty sure what he would do. He would do something. Oh, films. He would do something like fmap.
You can do without the lambda.
He would do these. I'm pretty sure he would do this.
I don't. He would not want to use the lambda.
Yes, that's what I'm saying. Like he would just do an fmap building those two.
But, yeah. So yeah, I guess that's okay already.
And blah, blah,
Yeah.
blah. Why not? Why? Dude, this is why I hate this language. Look at this.
You hate what?
This language. Use record blah blah blah, and then found a lambda, and then it says why not data b functor second reduce type min like.
Actually, I would love this function.
Okay, let's see what is the Haskell way. So we would pick just. Okay, so we can pick the composition of
We
the
already
tuple.
told you the ins.
Why not data b functor second reduce type?
Yeah, just
Is that a
put there.
function? What is the data b functor thing? Second, data b functor This is not even here, man. Or is my LSP broken?
They are giving the full config name, I guess. Or maybe you need to import something, maybe.
That's
But not to import it. Oh, I don't know.
data b functor. Oh, it is actually quite smart. You see? B functor second. Oh, man. Okay, and then we do this.
You still need the parentheses.
Yes. This. And then it's saying non-exhaustive pattern matching, but who cares? Okay, just
Where?
I don't know. Oh, on the alias. We don't have an
Oh,
alias.
sure, yes.
And then we do the dollar. Okay.
Yeah, let's leave this incomplete for now because it's trickier to do the alias. Like we don't know exactly what we want already. Yeah, so let's go back to type checking there.
Now, let me just say one thing. Like on that defunctor thing, do we have things like third. We don't, so it's just like, well, bfunctor, right? Makes sense. It receives two functions. I'm gonna see, do we have docs? You do. Bfunctor is a type constructor that takes two type arguments, and is a functor in both arguments. That is like unlike with a functor, type constructor such as either does not need to be partially applied for a bfunctor instance. And the methods in this class permit mapping functions over the left value and the right value. Both
at the same time is really cool.
Yes. Okay. I still don't like the mathematicians. Okay. So the kind we can ignore for now. Actually, I think we are really doing the kind. Let me see. Yes, we are.
Yeah.
So
Right.
let's do the
Wait, what the fuck is that? If star.
So okay, this is a function helper. So if everything that
Yeah.
we've made a for is a star, then it's okay, it's a star.
So
Otherwise,
let
it's
me
an
see.
error.
Like you get the times, you are time checking that. And if all, if star, then it's just, yeah, it's correct, right? Let's just do
So okay. So what
type
else?
check.
The type check for the anonymous record.
Yes. Okay, so you separate both, you type check the expression.
Oh, to be
Don't
fair,
we-
we don't need to do this, right? We can
Well,
do
that's what I did, right?
we can do
Now you have the second, right?
oh expires. We can do this. Yes, but we could do this with the unzip, that's what I'm saying.
Oh, okay.
Then it's the same, I
But
guess.
if you are doing that, why don't you map only the thing without this construct? We don't need to disconstruct anyway.
Map, you mean here?
No. What I mean is, instead of unzipping and zipping, you can just like map the second, right? As we did with the other down there. But it's the same thing.
Oh yeah, I see.
So let's see. We get the types there. Yeah, the only thing it changes, and that's kind of for performance and kind of for being sure that we are not forgetting. We need to sort them by the name. Yeah.
Why do we? Okay, choose compare, right? I guess.
Yeah.
Like if you compare, you would want to get the name. So okay, we would have to sort only by the
label,
name.
right?
Yeah, only by the labeling. So okay.
Good luck, my kid. I trust you.
Oh, I think it might be easy. Let's see.
I bet.
So okay. Oh man, this is trash. Okay, let's refactor this because I think it will be harder this way. So okay, we just want, instead of doing this, let's do this for on the second map second of the fields. And then we just do this again, so we get like checked fields. Oh, sorry, checked expressions. That's
Wait,
it.
what that changes?
Nothing. I'm just declaring here, so I don't need to do the. Oh, do this a for. I cannot do this. Oh man. That changes that it's wrong. That is what changes. Yeah, I need to keep it this way. Okay, I didn't want to do this, but that's fine. So I know.
We need.
Let me do the normie stupid way. So I think it would be just doing sort. We have sort by. We do, and we can pick a function. Okay. And then a list. Okay, so we can pass. We can zip it in a list of the labels and the types. I'll keep it that like that on the other place. And then here let's do the lambda because it's easy. The lambda will pick the label and whatever, and then just sort by view. And then the sort by goes here.
There's something sus about it because you, yeah, the sort by or
Wait, it receives two things of the same kind?
yeah, right? You
Oh,
have
it's a
to-
comparison. Oh man.
Let me look on Google. Right?
Let's see. So, can we compare strings?
Of course we can.
No, but like I mean, less than. Does it make sense in Haskell?
I'm not sure. Maybe you have compare
Let's see.
or just sort.
So we have habemos Haskell. So let's do this. And I think it was T, right? On. Okay, let's just try to do ABC. This is less than ABD. True. So you do. What about ABC? False. Greater than, I think it's the same, or equal. Yes, true.
Wait, take a look on the signature of that. Yeah, we don't need that. I think we want compare Magenta because it needs to return the ring and not true.
Yes.
Try to use compare function with that, like
Is it
lowercase c, I guess.
compare? Let's see this. Compare.
Yeah, that's what we need.
Okay, I see. So we receive. Okay, in this case we
Suppose
can
you get
do.
the strings and compare them.
Isn't it just ABC? Oh, I see. This ORed. Okay, we receive two things, right?
Yeah.
Mm-hmm. Okay. So we dismember. Oh, wait.
Yeah, you receive like two tuples, right? You get both labels and compare them.
Yeah, I see. So label 1, label 2, and we do compare label 1, label 2. Why is it still complaining? Variable, blah, 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 sort by, ordering, types, blah, blah.
Is this lambda correct? Are the parentheses correct?
Yes, they are.
Variable not in scope. Sort by. Sort by is not in scope.
So wait, why is it inferring the type then? If it's like an import issue, I don't think it is, man.
Sure, that's what he's saying. You can try to compile.
Yeah, okay, that's the grub way. Yes, I want to save it. Thank you for screaming. Import the data list. Oh, I see. These, I guess.
Pretty sure that's ascending order, right?
I have no idea. But it shouldn't matter, right?
Huh?
It shouldn't matter, right?
Well, it only matters if you are consistent, but it's good to know.
Now we can test here. So sort by.
Let's use the AB, right?
Yes, but then we need the lambda. Okay, just an A and B we don't need, right? So
Let's compare AB. Oh, wait.
yeah, I see. Compare. And then we pass a list of. How do I make a list in Haskell? It looks like this.
Wait. Variable not in scopes.
So
Yeah,
okay,
Yeah.
it was already ordered, but yes, that serves the example. Okay, so let me decrease this. Okay, let me just see one thing. Haskell, there was another thing here. Haskell mode. Was it stack? Stack. There was a mode that
Are you
integrated with the
looking?
project. There was a mode that integrated with the project, so you could already load the project here. But I think I can load the file, right? But anyway. Okay, so let's keep here. Okay, so we were doing, where is it? I lost. Here. So we just do this. So we can compose the compare with the second. But then it's 2 arguments. No, right? We will need to do a tuple. No, on first. Dude, I find it very hard to think like in terms of this.
Wait, what's your question?
Yeah, because like compare has 2 arguments, right? And then I was thinking if
Yeah.
there's any other like better way to, instead of doing this lambda,
Well,
would be
there is, but you
composing
don't want to
this.
see.
I don't want to see.
You don't.
Why?
Because you probably want to transform the 2 arguments in a tuple.
Yeah,
Then you
that's
want
what
to
I
use
was
the
thinking.
defunctor to map both.
Yeah, I was
Then
thinking.
go back to normal arguments and
Yeah.
then return the compare. So yeah, you don't want to see that.
Yeah, I was. Oh, okay. We have that defunctor thing, right?
Yeah, man, but just let it as it is. Like
Yeah,
you already
okay.
have like too much stuff to do.
Yeah. Okay. So.
We need more stuff, right? Wait. Let's just check the evaluation part. Just like, did you guys have a value for that?
If we had a value for this.
Yeah, for the news record.
Yes, we are doing values.
Where?
Here.
No. What I'm asking.
Yes.
Oh, V record. Yeah.
Yeah.
But. Oh, that's very interesting. Yeah, I don't guess we need more than one record value.
Oh no, dude, no, dude.
Oh, what are you saying?
For now, let's just keep that way. You're talking about the anonymous, make a distinction between the anonymous.
No,
and
I'm saying the opposite. I don't think we need more than one.
Oh, okay,
the
yeah,
only
because
way
if they
they
get
are,
involved. Yeah, but we need to sort anyway, right?
I don't think we do
Oh,
that.
on the value, no, it's just on the type that we want to compare, right?
Yeah, let me just see the thing. So on this values.
Oh, actually, if you want equality on values of records, you do, right? Yeah, if we want equality, I think we do.
If you want equality.
I'll just leave a comment here. To do. Add a sort by. So we can have
Equality.
value equality. Yeah, so like.
Okay, I see. Like the built-in operators would have that. The user cannot do that.
Yeah.
But if it's a native function or like operator, then yeah, you might want to do that there, so you don't need to do after here. Okay.
So okay.
Yeah, but that's okay already. Man, are we missing something regarding anonymous record? Can you give a search on the name anonymous record?
So let me see. We have kinds. We have the reduction. The type checking, evaluation. No, I don't think so. What was the question you made?
Oh, equality, right? I was
Yeah, it's just
asking for
equality.
you to search for the name anonymous record.
Search for the name anonymous record.
Yeah, to see like all the places in which it appears. But I don't think we need that. I think only equality.
Yeah, just equality.
Oh, and also type substitution, I guess.
Oh, that's true. That's true.
Type stuff later.
Yeah, on the type substitution, I think it's easy, right? You just go on all the
Yeah,
fields.
just recursive.
So it's the same as the list, I guess.
Yep. But like conserving the
Yeah.
label.
I think.
you want, you can use the pre-functor stuff.
Mm-hmm. Okay. This I don't remember where it was from. I think it was data bfunctor. Let me import that. Import data bfunctor second, yes. And then where is it? Here. And then let me see what you were doing here. So we have this type substitution function that takes a placeholder, which you are just propagating, and the type. Okay. What is that target again? Oh, the target is the thing itself, right? Yes, okay. We're pattern matching it. We want to replace on that. So, okay, we can do... Oh, wait, sorry, Nata.
How do we use that again? Can you take a look on the other?
So, what do you think is on the other, what do you mean?
The other use of pre-functor.second.
Oh, I see. I don't remember where it was. I think it was here.
Just like, right?
So we're mapping with the reduce. But here we're f mapping with this function here. Can we do second? I think we need to compose in this case.
Yeah, but then for me.
I'm confused. Wait, this is just a partial function at this point.
It's not compose, it's applying, right?
This is a partial function.
Oh, wait. No.
Yeah.
Oh, shit, that's confusing. That's...
On this list type, which, okay, in our case it's... Oh, wait, no, I'm modifying the list, man. What am I doing? List type.
Oops.
Dude, I really don't like this language. I feel uncomfortable, man.
Okay, because you don't know it.
Yes, but I didn't feel uncomfortable like this in F sharp. Like it was, even in Nekoma, man. Like Nekoma was. No, okay, but like.
And they even less stuff.
It has a lot
but
of
man,
quirky
just
stuff.
use the apply instead of markering. Like the dollar, right?
Yeah.
No, not there. Like, no, not there.
What do you mean?
Between second and type substitution column. Right?
Okay, I see. So you want this and this to remove the.
Yeah.
This.
Yeah, I guess that's done, right? Yeah.
Oh, dude, I didn't know, but Lemon said there is this, which is like you read from the left instead of the right.
Yeah.
Like on this, on the dollar, you read from the left. Oh, sorry, from the right, right? Like the dollar.
Oh, okay, you mean it's a reverse application, right?
Yes. The ampersand is the opposite. Okay, so fields. That's it, I guess, right?
So basically, it's your pipe, Magita.
It's your the pipe, yeah.
Yeah, I guess that's okay already. Now we need to do the equality.
Do we need to do that? I don't want to.
We do.
No, but wait, equality on a value or no, right? That's not what it's saying.
Equality on the type. Type equality.
Where is it? Where is that thing, man? I don't even know.
The data type. The type data type.
Oh, it's an. I think it's a type class, right?
It's the right.
Yes. Okay, so where the thing is?
Where is the type?
Types.
Data type.
This.
There.
Deriving.
So you are
equals.
deriving the equal. You are probably doing a special case for other stuff. Now, let's.
We're not
I guess
even.
we can do the assumption that it's always sorted just because, well. Now I ask myself, does the normal deriving already works for that? I
Well,
have no idea.
you have a comparable key, which is the label, and the other thing, which is also comparable because it's also a type. So
Assume that
assuming.
they are sorted,
Yeah,
then have the equality for the list, they probably have to be the same length, and recurse the equality.
yeah, I think so.
And then the tuple, the same thing, you just recurse.
Mm-hmm.
The strings are the same, the type are the same. Yeah, I guess it works, the deriving for that. We just have to be sure they are always sorted already, right?
Yeah,
The equality should
which
not
is
have
just
to
not the case for the evaluator, but who cares?
Wait, a data type application. Dude, I guess we are maybe doing something wrong with our equality, man. Oh, now I remember. Now I remember. You guys wanted to always reduce it first because you would need to do a equality
Mm-hmm. Yeah, that I remember.
overwriting the deriving, right? I see, I see. Yeah, then it's okay already. Just remember to reduce it first. Yeah, okay, so we are done with that also. So yeah, Magenta, what you can do for us to be sure
Let me commit
is to
this.
do a
Do you want me to load on the REPL?
loading what?
Well, I can load and test on the REPL, that's what I mean, by the AST.
No, we don't need. Yeah, what would be better for us would be if you do a global search on the type of records and the expression of records, of anonymous records, right? So we can be sure that we are not forgetting any
Oh
function.
man, I need the F sharp. FSI, wait.
So it doesn't bite us like months from now.
Wait, say it again?
Do a global search for the type of the anonymous records and then the expression, so that we be sure that we are not forgetting something that will bite us like months from now.
So the type of the anonymous record and the other thing.
Yeah, like the anonymous records. Do a global search for
So okay, this is everywhere. So it's on
that.
here.
Okay.
We just changed that. That is
Yeah, but
on
we
the,
don't know where those are, right?
oh, I do. Here.
Well, those we know their substitution because you are using the function there. But what about the second?
Yeah, the second is just the declaration on the
Oh,
ST.
okay.
This one
nice.
is on the, yeah, this is just an import. This one is we just did. This one I don't know.
We're doing the convert.
So this is the kind checking.
Okay, kind check it's okay.
This one is the reduce, which is also okay.
Okay.
And this one is the
What? Reduce again?
what? Oh, okay. This is the pattern
Oh,
matching. This is the
yeah.
okay. Yeah, I think that's it.
The compare was about what again?
Oh wait, sorry.
Oh, it was the sorting, right? In type checking.
The compare. Yes, it was the comparable. But it implements
Now-
the interface comparable. No,
Yeah.
it's the
Now
ordering.
just look for the expression, right? The expression. How was it?
The E anonymous record, I think. Okay, it is compiling. E unknown. Oh, it was pretty fast. This is just the declaration. Let me just confirm what is a field. Okay, it is the tuple.
Why they did that?
Yeah,
Oh, nice.
don't ask me. Okay, this.
Oh, okay, yeah, because it receives the expression to type check, right?
Mm-hmm.
And the last one
Yeah, it's also just receiving.
is
And
the eval, right?
yeah, okay.
Nice, nice, nice. We are done with the anonymous record.
Let me commit this.
Yeah, that's better.
Because I get anxious whenever I see Lemos doing like a shit ton of files and he doesn't commit anything. Okay, Visa just added the environment. Should we modify? Oh, but I think we modified these other files, right?
Wait, can you repeat?
Yeah, because it's complaining, not complaining, but it is just saying, okay, but you added this on the context, but did we modify the context anywhere else or just here? I remember we did it in other places.
I'm still not understanding.
Let me see. Okay, we added here. Because I don't want to commit both. Well, let's do it. What? Demos removed features? Oh, removed, I think, yes. Okay, fix unknown records. Okay, so what were we about to do? We were doing the declarations, right, before?
Yeah, now I need to deal with the fucking type alias declaration.
I think it is on the evaluate. No, the type check.
Take a look on the eval first because it's just ignoring. Where is the eval declaration?
Evaluator eval declarations.
Okay, there. So you're matching there the. Oh, okay, expression. Yeah, basically we just ignore it.
Mm-hmm.
So you need to return an eval when. So you just return the one that you got, I guess.
Yeah, for the evaluator, we don't care if to add it to the environment, right? So we just return.
Yeah.
So what is the thing? It's not inside the.
Wait. Actually. Oh. Whoa. Actually, we do care.
Why?
Because we need to add the functions, right?
To add the functions.
Yeah.
What do you mean?
Yeah. So when you are declaring a sum type, yeah, then you want to add functions in the context. I guess.
You want to add functions in the context.
Yes.
I see. So you want to add like the cases, right?
Yes. Yes.
Mm-hmm. Let's ignore this for now. Let's just leave a message to do.
Yeah.
Add cases of a sum type.
In the context as functions.
Let's do.
Yeah, that's good.
To the.
Then,
Now your project becomes real.
Sorry.
Because you're looking to the messages.
Wait, sorry, Commander. I didn't get it.
I said your project becomes a real project because it has to do messages now.
Oh man.
just change that for something that people can understand and instead of you.
Add cases of a.
Even
Case.
like say discriminated unions or something. Like
Okay,
don't
this-
use the abbreviation.
Discriminated union.
To the context as functions.
To the context as functions. Okay, and here we're just gonna reply for now. So we already have the nth, which is there.
Oh,
That
it's
is-
ACC.
It's ACC, yes. Okay. What?
What?
Oh, it's a monad
Oh,
thing.
yeah.
So yeah. What is this value complaining? It's bindings.
Good
It's
question.
shadows. Shadow.
Oh, fuck it.
Okay. I gotta remove the warning. Let me see what it is. Why name shadowing? Screw you, Lemus. Oh, I thought I just mentioned screw you, Lemus, and he joins. Like that would be funny.
You're so mean.
Okay, so here's the drill. It's type check declarations. Now this is the thing that so we marked as undefined. Let's see. Ooh la la. So what we do to type check is we need to type check every Ooh. So a declaration is quite easy, right? We just check the members it has.
Wait, can you? I'm not understanding what
Like
you said.
type checking a declaration for a sum type is just checking the things inside of it, right? That's not hard.
You don't. Type check declarations. Like you don't type check anything. They are types already.
Yeah, that's true. Makes sense.
What you need to do is to do different pattern matchings. Oh wait.
Why pattern matchings?
Wait. It's because some stuff you have to treat it differently.
Dude, we can just ignore this, can't we?
What do you mean, man?
No, dude, on the declaration, we don't need to do anything.
Of course we do. We need to at least add in the context.
Add what to the context?
Well, the type alias, right?
Oh, I see. This is the declaration. Yeah, makes sense. So we end
Yeah.
with the label, then yes, okay, makes sense. So let me do it. So
Well,
map,
first you kind of check the type.
let me just do the map first. The add thing. I think what was the name? It was alias context. This map insert.
The dudes don't have records.
Oh, dude, look at these operators, man. It just, and my sanity just drops whenever I have to. Insert with that name on that type, but then we're gonna change a note, but I'm just add it here. And then we are dismembering the record, so it's just alias context. Okay, now, wait, and we need to do peer. Okay, so let me think. So this dude here, let's do a do notation. Do we need do notation?
Yeah, we do.
Yeah, okay, we do. Thank you. Okay, so we need to kind check everything inside of that and see if all of them are stars.
Not everything, right? You have.
Yeah, okay, you might have. Wait, say it again?
You don't need to kind check everything. You only have one type. When you send.
Ah,
them,
yes.
you kind
So,
check the type,
yeah, okay.
They will do it for you.
Mm-hmm. So, kind check environment ACC type blah blah blah. Yeah, and then with this we do the case kind of.
No. We
We don't care for the case, right? It's just
Yeah,
a type.
we don't.
Yeah. So
You can. Wait.
So wait, so we also have this, right?
Yes, exactly. We also need that. Almost sure we do.
With this name as well.
Yeah. Yeah, exactly.
Okay, what was the other? Oh wait, how do you do records in Haskell? Oh man, no. You're gotta be kidding that I cannot do multiple declarations. No man, there's no way. This is true. No, I refuse. How do you do like overwrite? Like you know what I'm trying to do? Like it's a with.
Yes.
How do you do this?
I don't know.
Oh man, Haskell is a meme. Let's see.
It
Haskell.
Record update syntax or something?
Record update syntax. Good. Shorthand way, blah blah blah. Who cares? Oh, it is comma. No, the dude is trying commas. Let's see. Oh no, it is commas. Okay, that's kind of weird, but okay. Ah man. this, and then this is wrong.
It's something. You are not. You are just creating a normal record. I don't think that's the one to. Oh, the ACC there is the one that is doing the part of the update syntax.
Yeah,
right?
I think so. Couldn't match the type t variable info with type text. So wait, there's the kind. What does this kind context take? Let me see on view. Oh, it's up here. Oh, this takes a t variable info. What is a t variable info?
What?
What is a t variable info, Nata? I don't know.
What?
It is a name text or a name ID
Oh.
text int. I'll just use name text. Screw you.
Oh, okay, I see. Oh, I don't even want to think about those, man. Not now.
Yeah, I remember of the random generation of the IDs, right? I remember we were.
Oh, let's see. The guy's
the
playing.
display thing. Oh man.
But
Thank
yeah,
you.
let's keep going with it.
Okay. So let's see.
I guess we are missing stuff for sure. Because, yeah, that works for a normal alias. Like, we kind check it if they are like well formed, right?
Mm-hmm.
We don't care exactly what kind they are, because they
Yeah.
could be something different than star.
Mm-hmm.
They could be just partially applying something,
Mm-hmm.
or it could be just, I don't know,
Yeah, I see. It could be like, for example, for
linked
all.
list, list.
Yeah. I see.
Well, for all is also star.
Yeah, like a car. Yeah. No, wait. A for all. No, wait, dude. What I'm saying is the T
Like,
application.
linked list
Yeah,
equals
okay, I see.
list.
Mm-hmm.
Okay, so we kind check them, since they are well formed. Then we just add its kind and its alias, right? Yeah. Yeah, but that only works for the alias. For the sum type, we need something different, right? Yeah. So you need to create another case, Mageta. A case.
We need to add to the ST first, right?
Why don't we have this thing already?
No, we didn't. I think I commented on the ST.
Okay, so you can just comment this also.
Yeah. Okay. Let me just put it here. Algebraic. And it should be this. No. Should be the name and a list of types here, right? In this case. Oh no, it is actually. Oh man,
No.
wait. It is actually.
You mentioned type.
It should have a name, and then.
No. If we are using the same node, you only do declaration type, name, and you match that type.
Oh, I
It should
see.
be
And then this. Okay, inside this, it should be this. I get it. So this is an algebraic, which is just fields, right? So. Okay, and this is not implemented, so let's just add it here. Wait, what? Oh man, dude, I think it bugged on the thing. Can I jump to this? I cannot. Can I jump here? I can.
What the heck is going on?
Oh wait, there's no declaration for an algebraic, right?
Yeah.
Okay.
We are trying to do
I don't know, man.
the,
Don't ask me.
the declaration of types coming. And I
Yeah.
guess we just got a problem, Mageta. Do you know the alias part, not having the type inside? That's a huge problem for you.
The alias doesn't have the type inside. Yes, okay.
Yeah, that's a huge problem for yours, man. Because when you want to give the error for that, you will not wait. Let me see.
Dude, you know what I'm tempted to vote for now? Have you seen the
What?
error messages in Clojure?
No.
They are unreadable.
Then
They are fucking Java backtraces, man.
Yes. So I'm proposing not caring about error messages at all.
Well, then not even you will understand it.
Yes.
Because take a look, Magita.
Mm.
You get the type of. Dude, that's fine.
But in our case, we don't even have a stack trace, right? So there's that as well.
What I'm thinking about is that if you get the type that it was like aliased, right?
Mm-hmm.
And you have just the type there. For example, you have a sum type and they are nominal. Then your message would probably be like talking about this sum type, right? Meaning that you don't want to talk about that. You want to talk about the name that it was alias to,
Mm-hmm.
right? So you complain about the list.
Yeah, you're
not
presenting.
About the sum type that has.
You're presenting something that the user doesn't know what it represents because that's just an internal representation.
Exactly. Like you want to see a error message about the list, not about the sum type that has new and cons.
Mm-hmm.
But can we do that without changing anything? I'm not sure yet, but we need a comment about this. And let's do that on the type data type.
So let me go here. Wait, I adding types already? No, I adding types. Here. Data type.
You could go like on top. Yeah, that doesn't mean.
Let me see. To handle proper error messages on algebraic types. Not only those, right?
We don't know yet. That's kind of a question we got. So let me.
Oops, let's go on the next line. We need a way to store its name if it's aliased. Well, it's alias, right? Let's put it that way. It's alias.
That's how much we're saying, not much.
Oh, that's .NET. Wait. No, it is saying like to handle proper messages on some types, we need to store its alias. Ah man, what the heck is happening? To reference the name and not the internal representation.
Yeah, why don't we just write, we might need to change the alias text to the alias text type to have better error messages. Because then we like even know what is the exact code that you need to change.
We might to change, say it again.
The alias text to the alias text type.
The alias text.
Dude, you're writing an essay.
The alias to the alien text type.
Yeah.
This. That's fine.
But that's okay.
In other words,
Oh, dude.
done.
If you have the other words, why don't you just use the other?
Nah, man, I wouldn't remember this. Dude, what the heck is happening? Look at this.
Yeah.
The Haskell
you have a
mode.
bad environment.
Restart. I hope it restarts. I live by this fear every day. I'm glad that I can compile this to begin with. Yeah, okay, it's yeah, okay. So what we were doing, I even forgot. Oh, the declarations. Okay, we added the declarations. Yes, but we are not handling. Okay, now we need to do the rest. Okay, we didn't add the algebraic to the types yet. This. So, okay, let's first on the types. Data types. Type. So this Okay, this is what we were discussing. This is it, right?
Wait, can you repeat?
So what is an algebraic type? It is a text, so like A, B, C, whatever,
Yeah.
and a list of types, so we can have like these
Yes.
handled in as partial applications. Okay.
Okay.
What about U, the expression? We don't need it, do we?
Even if you're going to use functions.
Even we don't. What did you say? You do or not? I don't
We
think we
do.
do. Why?
Let me see.
Because the only thing I see is having the declaration. Like this, I don't think it makes sense.
Because you need that for at least the values, I guess.
Oh,
wait.
I mean, no, right? Because we should add those in the environment already. On the declaration. Like, let me remove and then let me go on the declaration part. Where are we?
When we type check the declaration.
No, this is the parser.
Add the environment.
Where was the declaration, man? That's the question now. Evaluator?
Okay.
Nope. Where are the declarations, Nathan? Me. Utils, I'm pretty sure it's not.
We need that.
Types, I don't think so. Trinity, type substitution.
Yeah, também we don't need that.
I don't think so, man. Because the way you are handling is kind of different. Like it is, I think it's REPL.
Yeah, it would need to be able to just like return
Here.
function that will return the value.
So let me see. Is he here? This is the REPL. So let me see. Let me see all the functions that are in this file. Import, type check eval, find special option. Yeah, I think it's that one. Let's see. We receive a text, an expression, and it's beta transformer. Then we pick type check eval, the body of the crap you sent. Yeah, but dude, this is like REPL specific. I don't think it is this.
Wait, what are you taking a look at?
What is CL, man? I was looking at the...
Yeah, it's like the command line stuff.
Oh, command line. Okay. Parser, don't think so. Evaluator. I'm looking for... There is a place where I said, okay, let's go back here later to add the stuff to the declarations. Like, for example, you define ABC, and then you have A, B, and C. And then you make functions of those things. But I don't remember where I left that. Oh, okay. Let's use the magic, not that.
Are we? But we are not done with type A. Wait, are we? We are not done with type alias yet, Nugget.
Yes, I know.
Then
We're adding both at the same time.
Take a
man.
look at.
Yes, but we were adding both at the same time. That's the problem.
No. You commented some types, right? We were doing anonymous records because they were already added, and then type alias, but not some types.
Just a second. Here, evaluator 66. Okay, let's not forget about this. This is stupid.
That's what I have it to do.
Yeah, it's okay. It's after this thing, eval declarations. It's a special thing. Okay, I'll just remember this. Okay, so what now?
Dude, some annoying parts. That might be a problem, like the typing that we were doing. It might be a problem with the whole substitution, equality, and...
Oh, no, I know what you're talking about now. I'm not gonna do that now, man.
That might be a problem. So I guess we can end by today, Magid.
Yeah, dude, we've been here for 2 hours already.
Because that will be the only thing left, I guess.
So let me see. These, we can, I think it's wise for us to make issues of those things on GitHub, and then we can comment there.
Maybe we can.
That's even more professional, I guess.
We are not professional.
I know, but it makes us look like we even have CI, man. So, add algebraic draft and alias. Oh, it's confusing. Add algebraic and draft. Alias draft. Yeah, just that. Let's end here, and that's it.